Now let's start with the next topic, that is the reinforced cement concrete, with our first subtopic, that is the singly reinforced beam by WSM. So we'll be starting with working stress method, as well as we'll cover the limit state method after that, and then we'll cover the pre-stress concrete. What are the topics which you have to cover under this? You have to cover the singly reinforced beam, doubly reinforced beam, T-beam, column, slab, footing, each and everything we will be covering in these sessions. Now first start with the singly reinforced beam. As you have already done with the objective portion, it means that you should know, at least you should have some idea regarding the analysis and design of a singly reinforced beam. Now this is singly reinforced beam which we are considering in this lecture. Always, whatever the beam is, there can be three different types of question which can be asked in the examination. That is the analysis of the singly reinforced beam. Then the question can be the calculations of stresses. The calculation of stresses, this can be the next topic. Next part that can be asked in the singly reinforced beam part. Third is the design of the singly reinforced beam. Design of the singly reinforced beam. These are the three topics which can be asked example. Now let's start with the analysis. Analysis, you already know that, as we have covered in the street portion, that analysis means the section will be given to you. What you have to do is that you have to calculate the load carrying capacity. But in the case of beam, the load carrying capacity is basically defined in terms of the bending moment carrying capacity. It means that whenever the beam is to be analyzed, what you have to do is that if somebody is asking you to calculate the capacity of the beam, it means that what you have to calculate is the moment carrying capacity, कि वो कितना moment carry कर सकता है. So let's start with our first part, that is the analysis part. Analysis part. Now, we are using the WSM method. WSM method is the method which is also known as the elastic method. Now, what is elastic method? Elastic method says that whenever the structure will be yielded, then you will consider the structure to be failed. The structure will not reach its ultimate state. You have to consider the structure to be failed whenever it will reach its yield state. Now let's consider that this is the cross section which we have. The cross section is having certain dimensions, that is, for example, B by D. There are basic things which you already know, that there are 4 number of bars which are present here. Let's say that this is 4 bars, each having 20 mm dia. The total depth of this cross section is given to us as 800 mm. This is the total depth of the cross section, and the effective cover is given to us. The effective cover is 50 mm. Always remember that the effective cover is measured from the center of the reinforcement. हमेशा ध्यान रखना है, the effective cover is measured from the center of the reinforcement. The clear cover is measured from the base of the reinforcement. So whenever somebody will ask you to calculate the effective cover, then it means that you have to calculate the distance from the center of the reinforcement to the bottommost portion of the beam. Now this will be the remaining portion which will give you the effective depth of this particular cross section. This small d, this will be equal to 750 mm. Now what is the width? The width is provided to us. This is 300 mm. This is the width. This is the case which is given to us. They are saying that we have M20 concrete. M20, M is the mixture, 20 is the characteristic strength of the concrete, and Fe415 is steel. Fe415 is steel. HYSD bars are used in the reinforcement. Now, these are the cases. They are saying that the permissible bending stress under compression, sigma CBC. This is the sigma CBC is what value? This is the permissible, or you can say that the maximum value of stress that the concrete can develop under bending compression. This is 7 Newton per mm square. This is given to us. Similarly, they have provided us with the permissible value of stress in the steel in tension. Steel में tension होगा. This is 230 Newton per mm square. This is given to us. M20 के लिए sigma CBC is 7M. Fe415 के लिए sigma ST is 230. These are the things which are provided to us. Now, in the case of WSA, one thing you have to remember, I'll upload a conceptual lecture also so that you can easily understand what exactly I'm going with. So do one thing. Firstly, go with that, the conceptual lecture which will be like uploaded with this particular lecture, and then come to this lecture so that you can have a better understanding of the method which I'll be टीचिंग ये यार ज्यादा बेटर क्लियर हो जाएगा। तो आप सबसे पहले एक बार वो कॉन्सेप्चुअल लेक्चर देख लेना जो मैं इसके साथ अपलोड करूंगा अभी सिंगली के एनालिसिस का, एंड देन कम टू दिस सो दैट यू कैन इजिली अंडरस्टैंड द कॉन्सेप्ट। फाइन। So here what we are doing exactly is we have these things, we have to calculate the moment carrying capacity. Moment carrying capacity of any beam is known as the moment of resistance, which is basically the force into the perpendicular distance. Now moment of resistance means the moment which is generated internally by the beam. Why the moment is generated internally? Because when you will be applying certain type of load over the beam, then beam will try to create a response against that particular load. While developing that particular response, what exactly will happen? What exactly will happen? For example, this is the axis along which the bending is taking place. This is the axis along which the bending is taking place. It means that along this axis, there will be the development of the opposite type of stresses, which will try to create a response against the external type of stresses. For example, the external load is acting, because of which there is external moment which is present. To resist that moment, there will be the internal response, the internal moment, which is known as the moment of resistance, which has been developed by the beam itself. And while developing that moment, the beam will also develop some kind of internal forces. And those forces will be as you have applied the sagging moment. Let's say that we have applied the sagging moment. In that case, the forces will be compressive above the neutral axis, and these forces will be tensile below the neutral axis. Compressive above the neutral axis and tensile below the neutral axis. While designing or analyzing the concrete beam, what we have to do is that we have to consider that the tensile stresses are only taken by the steel. You have to ignore the tensile stresses handled by the concrete. It means that the concrete which is present below the neutral axis is of no use. The concrete which is present above the neutral axis will be fully utilized because the strength of concrete is maximum under compression. ये तो simple सा concept हुआ। दूसरी चीज, whenever you want to analyze any structure that is made up of concrete or RCC, you have to take a certain assumption into consideration, and that assumption says that the structure, the beam is homogeneous, elastic. It means that this structure, this beam, this cross section which you are just looking at, this is not homogeneous, because here this is steel, here this is concrete. We have three different materials which are combined together. It means that to make it homogeneous, what you have to do is that you have to convert this steel into the equivalent concrete. To convert this steel into the equivalent concrete, there is a ratio which is known as the modular ratio. We will multiply the modular ratio with the area of the steel, and this MAST is now the concrete, which is equivalent to the AST amount of steel. So MAST is basically the equivalent concrete which is equal to that of the steel which is in front of you. इस steel की जगह आपने इतना सारा concrete लगा देना है, and this concrete will have the area which is MAST. ये पूरा MAST का concrete आप यहाँ पे put कर दोगे, and now your beam will become homogeneous as the beam is now having only concrete throughout the structure, that is having area this much above the neutral axis and only area this much below the neutral axis. This much area only below the neutral axis, because always remember that below the neutral axis you will not consider this portion of concrete, you will only consider this portion. And why you are considering this portion? Because in this portion only the steel is present, but you are just replacing that particular steel with the concrete so that we can properly analyze. Now this is the case. Now what you have to do is that you have to check for the value of M. M is the modular ratio, which is equal to 280 upon 3 sigma CBC. This relation is given in the code. When you will calculate this value for this particular cross section, this is 280 divided by 3 into sigma CBC. Sigma CBC is 7, and this value you will get, this value will be equal to around 13. This value you will get around 13. So 13 will be the value. Let's say that. Fine. अब बात करते हैं एनालिसिस की। एनालिसिस की बात करते हैं। एनालिसिस का मतलब होता है you have to calculate the moment of resistance. There are certain number of steps which you have to proceed. The first step is you have to calculate the actual depth of neutral axis. Actual depth of neutral axis. Neutral axis is that axis along which the section is getting rotated, along which the stresses are of opposite nature. Top and bottom of the neutral axis will have opposite nature stresses. So firstly what you have to do is that you have to calculate the actual depth of neutral axis. Let's say that the actual depth of neutral axis from the top is denoted by x actual. So to calculate the actual depth of neutral axis, you have to equate the moment of area. This is the first step. Equate the moment of area. Remember that we are using working stress method, equate the moment of area. For this cross section, when you will equate the moment of area, you will get ऊपर वाले एरिया का मोमेंट, ये विथ b है, तो b into x से, दिस इज एरिया, b into x से, मोमेंट ऑफ एरिया इज यहाँ से CG से यहाँ तक का डिस्टेंस, दिस विल बी x by 2 which is b into x square by 2. This is equal to the moment of area below the neutral axis. Below the neutral axis, this area is not to be considered. What is considered? This portion is considered. What is the area of this portion? This is MAST. Now, what you have to do is that you have to multiply with the distance. Distance will be from the center of this reinforcement to this particular point. Center of this to this point. This is the distance. It means that you want this distance. So, if we'll subtract XA from the defective, thus we'll get the distance from the center of reinforcement to this point. It means that this will be D minus XA. Now, let's put the value. You already have the values given to you. You can just put the value in place of B. B is 300. So, we will put 300 into XA square divided by 2. This is equal to 13 into AST is 4 into pi by 4 into 20 ka whole square. 20 is the diameter. Bracket 750 minus XA. Now what you will do, you will calculate the value of XA from here. XA can be calculated by using the calculator, as the equation formed is a quadratic equation. This will give you the value that is equal to 236.48 mm. This will be the value 0.48 mm. This is the value of XA. It means that the actual depth of neutral axis is this value. Now the next step is to calculate the critical depth of neutral axis. Critical depth of neutral axis. What is the critical depth of neutral axis? Critical depth of neutral axis is that depth of neutral axis at which both the concrete and the steel will fail together or simultaneously. It means that if the neutral axis is equal to the critical depth of neutral axis, then the concrete will also get failed and the steel will also get failed of neutral axis. Let's say that we are denoting this with XC. Code says that this the critical depth of neutral axis XC is equal to K is a constant into the effective depth D, where K is equal to, where this K is equal to M into sigma CBC divided by M into sigma CBC plus sigma ST. This is the value of K. You just have to put the values. This is 13 into 7 divided by 13 into 7 plus 230. When you will calculate, you will get this value equal to 212.61 mm. It means that this is the critical depth of neutral axis. ये critical हो गया, ये actual हो गया. Now what you have to do is that you have to compare these two cases. The third step is step marking होती है. You have to remember all the steps. The third step is you have to check for the type of section. For the type of section, there are three types of sections. One is the under reinforced section, another is the over reinforced section, third one is the critical section. Critical section means कौन section होते हैं? One, when XA is greater than XC, actual depth is greater than the critical depth. Second, when XA is equal to XC, and the third is when XA is less than XC. This type of section in which actual depth is greater, this is known as over reinforced section. This is known as the critical section. And this is known as the under reinforced section. Now let's see this. ऊपर वाले पे देखो, यहाँ पे XA is to 36 point something and the critical depth is 212.61. It means that for this particular case, XA is greater than XC. It means that the section is what? Section is over reinforced. This is over reinforced section which is present here. Now, if the over reinforced section is present here, so it means that now you have to analyze this particular beam for as considering the section to be the over reinforced. Now, when the section is over reinforced, now how to consider? Let's see that. Over reinforced के लिए अगर आप बात करते हो, now how to proceed? You have to see that. Over reinforced section का मतलब होता है reinforcement ज़्यादा है. Reinforcement ज़्यादा है, इसका मतलब स्टील ज़्यादा है. इसका मतलब स्टील की जो प्रेजेंस है, that is more. स्टील ज़्यादा है. अगर स्टील ज्यादा है तो वन थिंग इज क्लियर, स्टील फेल नहीं हो सकती है क्योंकि वो ज्यादा है. इसका मतलब पहले फेल होने के चांसेस किसके हो गए? कंक्रीट के हो गए. इट मींस दैट फॉर अ पर्टिकुलर क्रॉस सेक्शन, इफ दिस इज द क्रॉस सेक्शन, नाउ फॉर दिस क्रॉस सेक्शन, इफ यू विल ट्राई टू डेवलप द स्ट्रेस डायग्राम, नाउ द स्ट्रेस डायग्राम for a critical section, let's say that this is critical, XU critical, this is the critical depth of neutral axis. थोड़ा सा ऊपर कर लेते हैं. This is the critical depth of neutral axis. Let's say that. It means that if you will draw the critical stress diagram, then the critical stress diagram should go like this. This will be the critical stress diagram. This critical stress diagram should go like this. But if this value is XC, then the diagram will be like this. But actually, the case is not like that. In actual, what exactly is happening? In actual, what is happening? The XA value is greater than XC. It means that the neutral axis is somewhat here. The neutral axis is somewhat here because the actual depth of neutral axis is greater than the critical depth of neutral axis. It means that this XA is greater than XC. When XA is greater than XC, then in that case, you can see that if you just complete this stress diagram from here to here, you can see that कि यहाँ पे कंक्रीट अपना फाइनल स्ट्रेस तक पहुंच गया है, बट स्टील अपना फाइनल स्ट्रेस पे नहीं पहुंचा है. स्टील इज स्टिल हियर. स्टील अभी फाइनल स्ट्रेस पे नहीं पहुंचा है. इट मींस दैट द फाइनल स्ट्रेस, द मैक्सिमम स्ट्रेस व्हिच द कंक्रीट कैन हैंडल इज सिग्मा CVC, बट द मैक्सिमम स्ट्रेस व्हिच द स्टील कैन हैंडल इज एट दिस पॉइंट. एट दिस पॉइंट द स्टील विल हैंडल सिग्मा ST अपॉन m ऑफ स्ट्रेस. व्हाई यू आर डिवाइडिंग इट विद m? यू कैन जस्ट रेफर टू द कॉन्सेप्चुअल लेक्चर. आपको पता भी होगा बिकॉज वहां ऊपर आपने मल्टीप्लाई किया है, तो देन यू हैव टू डिवाइड हियर. यहां से हम डिवाइड करना पड़ेगा आपको. नाउ दिस, लेट्स से दैट दिस इज ऑब्वियसली लेस देन सिग्मा ST अपॉन m. लेट्स से दिस इज T by m. So it means that in actual the steel is not getting failed, the concrete is getting failed before that. It means that if you want to calculate the moment of resistance, which is equal to the force into the perpendicular distance, to calculate this, firstly, we have to calculate the force. Now, force is basically what? Force is equal to area into the average stress. Force is equal to the area into average stress into the perpendicular distance. Perpendicular distance in case of concrete, you have to call it lever arm. This is known as lever arm. Now, what is this average stress, area and all that? Let's see that. यहाँ पे you have to write calculating the force from compression side. Calculating the force from compression side. Always calculate the force from the compression side only. Compression side is which side? The side which is above the neutral axis is the compression side. The side which is below the neutral axis is the tension side. Now, in this compression side, the stress is varying from sigma CVC to 0. It means that there will be some stress which will be acting somewhat here. Let's say that this is the force, tensile force. Below the neutral axis, you know that this area you need not to consider. It means that the tensile force which will be acting only at this portion, this will be equal to FT. This will be equal to FT. Lever arm is basically the distance between these two forces. This is known as the lever arm or the perpendicular distance. This is the lever arm, which is the distance between the two forces, lever arm. Now what you have to do is that you have to calculate the force. Force का मतलब area into average stress. तो मोमेंट ऑफ रेजिस्टेंस के लिए डायरेक्ट लिख लेते हैं. एरिया की बात करते हैं. किस पोर्शन के लिए लिख रहा हो? कंप्रेसिव पोर्शन. मतलब इससे लिख लो या इससे लिख लो, बात तो एक ही, क्योंकि इस पॉइंट पे क्या है? फोर्स. इस पॉइंट पे स्ट्रेस 0 है, तो मोमेंट इस पॉइंट पे ही ले सकते हो आप. तो आपने क्या करना है, या तो ऊपर वाले का लिख लो या नीचे वाले का लिख लो, दोनों का मोमेंट ऑफ रेजिस्टेंस सेम ही आना है, बिकॉज इट इज द प्रॉपर्टी ऑफ द क्रॉस सेक्शन. तो वी आर कंसीडरिंग फ्रॉम द compression side. The force is area. It means that you have to consider the area till the compression side. Area is B into XA. This is area into average stress. Average stress is sigma CVC plus 0 divided by 2. Area into average stress into the lever arm. Lever arm is what? Lever arm is the distance from this point to this point. It means that from this point to the topmost point, the distance you already know. This force will be acting at a distance of CG of this particular triangle, which is equal to XA by 3. It means that the lever arm will be equal to D minus XA divided by 3. So what you have to do is that you have to just put the value. All the values are with you. XA you have already calculated. Sigma CVC value is with you. B is with you. You have to just put the values and get the answer. The answer, when you calculate, this answer will be around 166.67 kilonewton meter. This will be the moment of resistance. इसको नीचे से भी निकाल सकते थे, जैसे मन होता है वैसे निकाल सकते हो. टेंशन से निकालते. Then in that case you have to just calculate this value, क्योंकि यहाँ पे sigma ST you cannot directly use because the concrete has not reached its final value. steel has not reached its final value. Steel yahin tak pahuncha, but concrete has reached its final value, so you can directly use that particular value in the case of concrete, but not in the case of steel. That's why we have used the formula from the compression side. But if you want to use from the tension side, then in that case you have to do first, you have to calculate the value of T by M by using similar triangle. Sigma CBC by T by M, this is equal to XA upon D minus XA. यहाँ से सबसे पहले आपको T निकालना पड़ता. And after the calculation of T, you can calculate the moment of resistance. The moment of resistance is force. Force is equal to area into average stress. Area किस पोर्शन का? ये वाली फोर्स सिर्फ इसमें तो लग रही है, तो एरिया से इसी पोर्शन का होगा. कितना एरिया था? M/T. एवरेज स्ट्रेस से इसी पोर्शन की स्ट्रेस कितनी है यहाँ पे? T by M. लीवर आर्म सेम रहता दोनों फोर्सेस के बीच का डिस्टेंस. D minus XA by 3. So this M will get cancelled out. So you will get T into AST into D minus XA by 3. Then also the answer will be same. You can calculate from both the ways, but here you have to apply one additional step, that is the calculation for the stress that is present in the steel. Fine. I hope that you have understood the case. This is for the singly reinforced beam. This kind of question they can ask in the examination. This is the first type of question in which only the moment of resistance has to be calculated. Now let's consider the second type of question. The second type of question is that question in which you have to check for the beam or you have to calculate the stresses. So let's see that also. Now let's consider the next question, the next type of question which can be asked in the analysis section. In this section, what they will say is that they'll provide you the section, they'll provide you the dimension, they'll provide you the loading, and they will ask you whether the following given section is safe or not. Safety. ऊपर वाले क्वेश्चन में क्या था? ऊपर वाले क्वेश्चन में you have to calculate the load carrying capacity. That's it. नीचे वाले क्वेश्चन में क्या होगा? You have to check for the safety of the section. Like for example, in this question, they are saying that there is a rectangular cross section which is having a dimension of 300 by 600 mm. This is having a dimension of 300 mm by 600 mm. This 600 mm is basically the effective depth. It is consisting of 4 16 mm bars. This is 1, 2, 3, 4. It is having 4 16.5 bars. This is 4 16.5 bars which are present here. Now they are saying that it is having a live load of, it is carrying a live load is given to you 20 kilonewton per meter. This is the load which is provided to us. Live load is this much. Fine. What you have to do is that they are saying that the beam is simply supported. The beam is simply supported, which is having a span of 6 meters. The span is 6 meters. Calculate the stresses developed and check for the safety. Calculate the stresses developed and check for the safety if the concrete is M20 Fe415. If we will use this concrete, इन्होंने ये बोला नहीं कि यही use किया गया है. They are saying that you have to check for the safety if we will use this particular concrete. Now let's see that. Whenever they will ask you to calculate the stress or check for the safety, you have to proceed a different way. In this question, they have provided us the ratio of the model ratio value to be 13. Now let's see that. We know that first of all, what we want is that we want to check for the calculation of the stresses. Stresses निकालना है safety पता करने के लिए. तो सबसे पहले एक काम करते हैं, total load निकाल लेते हैं जो इसके ऊपर लग रहा होगा. हमारा एम क्या हो रहा है? हमारा एम ये है कि we want to calculate the stresses. Stresses निकालने के लिए हमें पता है the formula of the moment of resistance is equal to force into the perpendicular distance. Force का मतलब होता है area into average stress. Area into average stress into the perpendicular distance. It means that if we will be able to calculate the moment of resistance, then the perpendicular distance we can easily calculate because we have effective depth and everything. Then we can calculate the value of the average stress. Fine. So let's see that how to calculate the moment of resistance. We know that the value of the moment of resistance should be at least equal to the external moment which is acting over the beam. It means that whatever the moment which is coming over the beam due to the external loading, at least the moment of resistance should be equal to that particular value. It means that the external load firstly we have to calculate. External load. सबसे पहले external load निकाल लेते हैं, then we'll proceed with that. External load की बात करते हो तो live load is already given to you. We'll first calculate the dead load. The dead load, let's say that the effective cover is 50 mm. The effective depth is given to us as 600 mm. It means that the dead load you will calculate, then the total section will be of 3300 by, this is 600 plus 50, this will be 0.65 into the unit weight of the concrete. This will be the total dead load. It means that when you will calculate the dead load, this value will comes to be, let's see that this is 0.3 into 0.65 into, this is 0.3 into 0.65 into 25. This is 4.875. This is the load which is equal to 4.875 kilonewton per meter. It means that the total dead load plus live load will be equal to 24.875 kilonewton per meter. We have to design for per meter length. Now the bending moment will be equal to 24.875 as the beam is simply supported. It will be having the maximum bending moment at the center. Remember that if the support is something else, then in that case also you have to calculate the maximum moment that will be present anywhere on the beam. We have to design for the maximum moment only. This is W into L square divided by 8. This value will be 11.9375 kilonewton meter. This will be the bending moment. It means that the external moment which is coming over the beam is this much. It means that the beam should develop at least this much of response. So the moment of resistance should have at least this much of value. It means that this moment of resistance should be at least equal to 11.9375 kilonewton meter. कम से कम इतना तो होना ही चाहिए. Now, you know that we want to basically calculate the value of stresses. The moment of resistance is equal to area into average stress. Area, if we are considering from the compression side of the beam, then the area is B into XA, area into average stress. Average stress is sigma CBC plus, or let's say that this is not sigma CBC. We don't know the value actually for the stresses. So let's consider as C. This is C into divided by 2, C plus 0 by 2 into the lever arm. This is D minus XA by 3. Now, you know the moment of resistance value. This is 11.9375 into 10 to the power 6. B value you also know, 300. This is XA. C value we didn't know. This is D minus, and XA is also unknown. So basically in this equation, two things are unknown. One is C and another is XA. If you want to calculate the value of C, then first we have to calculate the value of XA. And you know that whenever you have to calculate the actual depth of neutral axis, XA is what? XA is the actual depth of neutral axis. Whenever you have to calculate the actual depth of neutral axis, then what you have to do is that you have to equate the moment of area. It means that you can say that this is B into XA square by 2. This will be equal to MAST D minus XA. You have everything. You have B, you have AST, you have D. All the values are already with you. This is 300 into XA square divided by 2. This is equal to 13 into AST is 4 into pi by 4 into 16 ka whole square. What is the depth? Depth is 600 minus XA. It means that from here you can calculate the value of XA. The XA value will calculate, and the value will be getting is 172.56 mm. Remember that here you cannot compare the value with the critical depth, because for the calculation of critical depth you must know the actual value of stresses, because critical depth is equal to K into D, where K is equal to M sigma CBC upon M sigma CBC plus sigma ST. But in this question the concrete and the steel are unknown. पता नहीं है कौन सी concrete steel use करनी है. ये हमें पता करना है stress निकाल के कि कौन सी concrete use करेंगे तो safe होगा. This is what the question is asking. Now you already have the value of X A. Now what you have to do is that you have to just use this value and put it here as well as here. All the things are known. You can calculate the value of C. When you will put this value here, the value of C will be equal to 7.97 Newton per mm square. It means that the stress you can calculate, this will be the safe stress in the concrete. Remember that this is in the concrete. For the steel, if you want to calculate, then you can just use the similar triangle. This is C upon, let's say that in the steel the stress is T by M. M is mandatory to be used. This is equal to XA upon D minus XA. All the values are known to you. This is 7.97 divided by T upon 13. This is given to you. XA we have calculated 172.56 divided by 600 minus 172.56. From here you can calculate the value of T. The stress value you will get, this is equal to 256.57 Newton per mm square. It means that the stresses that are developed in the beam are having the values. Concrete के अंदर क्या हो रहा है 7.97, स्टील के अंदर क्या हो रहा है 256.57. अगर क्वेश्चन में आपसे पूछा गया, जैसे मैंने आपको बताया था कि if we are using this concrete and this steel, whether the section is safe? No, the section is not safe, because in case of M20 the sigma CBC value is 7 Newton per mm square, and in case of Fe 4.5, the sigma St permissible value is 230 Newton per mm square. But in this question, the values are more than the above permissible values. It means that the M20 and Fe 4.15 soft cross section cannot be used. M20 and Fe 4.15 cannot be used in this type of cases. समझ में आ गया? तो this is the second type of question which can be asked in the examination. You have to check this particular value. ठीक, तो ये आपको ध्यान रखना है किस तरीके से अप्लाई किया जा रहा है. I hope that you can understand the case. Fine. Now, as you have understood the two basic type of questions, one is the calculation of the moment of resistance. Another type of question is basically the calculation of the stresses, or you can say that it is calculation or checking for the safety of the section. Now the third type of question is the design of the section. Design of the section, which is the third type of question that can be asked in the singly reinforced section. Design of the singly reinforced section. देखो डिजाइन का सिंपल सा फंडा है. इन द केस ऑफ डिजाइन अभी तक क्या हो रहा था, आपके पास सेक्शन गिवन था, सब कुछ गिवन था. इन द केस ऑफ डिजाइन नथिंग विल बी गिवन टू यू. यू विल बी प्रोवाइडेड विद द लोड. आपसे कहा जाएगा इतने लोड को रजिस्ट करने के लिए जस्ट डिजाइन अ बीम. इट मींस दैट you will be provided with the load. What you have to do is that you have to design the beam. It means that you have to design the dimensions. एक तो आपको डायमेंशन पता होनी चाहिए बीम की, क्योंकि आप डिजाइन कर रहे हो तो आपको पता होना चाहिए उस लोड को रजिस्ट करने के लिए क्या डायमेंशन होना चाहिए. This is the first thing you should know. And second is the reinforcement that you have to provide. That is the area of steel that has to be provided for resisting that particular type of load which is acting over the beam. So let's say that what we have to do, let's consider an example question here so that you can have a proper understanding. Remember that in the case of design, the answer is not checked. You have to just write the steps properly. The step marking is there. Answers for different students will be different. So you have to just concentrate and focus more on the pattern and the method and the representation of the answer. Fine. In this question, they are saying that you have to design a reinforced concrete beam for a load of, the load is given as, the live load is provided to you, for a load of 50 kilonewton per meter. अगर ये आपको लाइव वर्ड नहीं देंगे, सिर्फ ये बोलते हैं कि the beam is to be designed for a load or for a UDL of this much, then it means that the self weight is included under this. If they will say like this, then you have to consider the self weight in that also, in that only. Fine. So let's consider that only so that you will not get confused. In the question they are saying that you have to design a reinforced concrete beam for a load of, लोड दिया हुआ है आपको, for a load of 50 kilonewton per meter. It means that the self weight is included under this. This is 50 kilonewton per meter, which is the UDL which is acting over the beam. The beam is simply supported and having a span of 8 meters. This is simply supported beam with a span of 8 meters. In the question they are saying that you have to consider this condition that the width of the beam should not be less than 400. इसका मतलब width should be at least equal to 400, should not be less than 400. The concrete which you have to use for the design is M25 with a steel that is Fe 415. These are the things which are provided to you. Now you have to design. Always remember that whenever you have to design, you have to first assume a certain depth for the section. You have to, सबसे पहले आपको क्या करना होगा, you have to assume a depth. Code के according या general consideration के according, the first depth which you will assume the effective depth equal to span upon 10. You will always consider this value. This is the first assumption which you have to consider, that the effective depth will be equal to span upon 10. That is, span is 8000 divided by 10. It means that the effective depth will be equal to 800 mm. This will be your first assumption. If the effective depth is equal to 800 mm, then the total depth, let's say that the effective cover is 50 mm, is 850 mm. Fine, this will be the total depth. It means that if the total depth is this much, तो आपके क्या करना है, let's consider that we are considering the width to be equal to 400 mm. It means that we are designing a cross section which is having dimension of 400 by 850 mm total. Now, what exactly we want is that we want to design for a particular loading condition. The load is given to us, load is 50 kilonewton per meter. First of all, let's calculate the maximum bending moment that is present over the beam. As the beam is a simply supported beam, so the maximum bending moment will be 50 into 8 square divided by 8. This will be the maximum bending moment, kilonewton meter. ये आपका maximum bending moment आ जाएगा. This value 50 into 8 का whole square divided by 8. Let's check this value, what this value is. This is 50 into 64 divided by 8. This value is 400 kilonewton meter. This is 400 kilonewton meter. This is the bending moment for which we have to design. Now you have the bending moment, you have assumed the dimension. Now let's see that how to design. Always remember that whenever you have to design, theoretically you always have to design the balance section. Whenever you will be designing, you always have to design the balance section. Now what is balance section? There were three different sections. One was under reinforced, other was over reinforced, and one was critical. The critical section is also known as the balance section, in which both the concrete and the steel will fail together. For balance section, the actual depth is equal to the critical depth on neutral axis, that is equal to K into D. This is equal to M sigma CBC divided by M sigma CBC plus sigma HT into D. This value is the balance depth, or the critical depth also you can say that. This value is fixed. Now, there is one condition that you must remember, that for the balance section, the moment of resistance can also be given as, this is equal to QB D square, where Q is equal to half into C into J into K. For the balance section, the moment of resistance can also be written like this. This is Q is equal to half CJ K, where K you already know, K is equal to M sigma CBC divided by M sigma CBC plus sigma ST. This is K. J is equal to 1 minus K by 3, and C you already know the stress which is present in the concrete. It means that for the above question, you already know that this value of Q can be calculated at half into, कौन सा concrete है, 25 के लिए C is 8.5. Now let's see this. J की value निकाल ली. K की value you can calculate. You already have all the things. D you have assumed to be 800. So you can calculate the value of the K. K की value जब आप निकालोगे तो you will get this value around 0.289. This value will be 0.289. So if this value is for the value of K, it means that this will be half into CJK. This is 0.289, and J will be equal to 1 minus K by 3. This will be equal to 0.904. This will be equal to 0.904. It means that you can calculate the value of Q. This is 1.11. This is the value of Q. It means that for the balance case, you can calculate the moment of resistance. The moment of resistance for the balance case is Q. This is 1.11 into B into D square. This is the balance moment. Now, what is the case? You know that whenever you will be designing, your moment which will be produced in the beam as a response, that should be at least equal to the external bending moment. जो moment body में produce हो रहा है, that should be at least equal to the external moment. It means that this 1.11 BD square, this should be at least equal to the external bending moment which is coming over the beam. That was 400 kilonewton meter. It means that this 1.11 into B, you already know 400, D, let's say that square, this is equal to 400 into 10 to the power 6. From here you will calculate the value of D. Let's say that this is D dash. Now there are different conditions. What you are doing is that, सबसे पहले आपने क्या किया? सबसे पहले आपने डेप्थ को अज्यूम किया, लोड निकाला, बेंडिंग मोमेंट निकाला, उसके बाद वो जो डेप्थ अज्यूम किया था वो चेक किया कि whether that particular depth is fine or not. अगर ये जो वैल्यू आपने निकाली है, if this D dash value is less than the assumed value of D which you have assumed, that means that the section is okay, the design is fine, you can provide or proceed with the assumed value. You can provide D जो आपने पहले assume किया हुआ है, you can provide D, not D dash जो आपने assume किया. अगर D dash छोटा है, but if D dash is, the calculated value is greater than D, then what you have to do is that you have to assume a new value of D. You have to assume a new value of D and repeat the procedure, and then you have to repeat the procedure. फिर से, for example, जैसे ये वाली वैल्यू आ गई, for example, this value comes to be 900 mm, ये आ गया 900. आपने ऊपर assume किया था D को 800. It means that this is the case. Now what you have to do is that your section is getting failed because the required depth is 900 and you are providing 800. Now you have to do is that you have to assume a new depth. अगर 800 से कम आता 700 700 प्रोवाइड कर दे, 800 प्रोवाइड कर देते, खत्म हो जाता है. Now you have to assume a new depth. Let's say that we are assuming D is equal to 1000 mm. Now you will repeat the procedure again. You will calculate the load. you will calculate the bending moment, and again you will calculate d dash by using the above relation. This d dash should be less than this 1000 mm again. जब तक ये इससे लेस नहीं हो जाएगा तब तक प्रोसीड करते जाओगे. जैसे ही ये इससे लेस हो गया, नाउ यू विल प्रोवाइड द वैल्यू ऑफ d which you have assumed, that is providing. अगर ये इससे कम आ जाता है, then you will provide 1000 mm as the depth and width. You want, if you want to change, you can change. If you do not want to change, you cannot change that value. It means that this is the section, this is the size of the section which you can provide, that is 400 by 1000 mm if the condition satisfied. Now the second case in the design is you have to calculate the area of steel, which is the second part of the design. To calculate the area of steel, you know that you have already calculated the bending moment for which the beam has to be designed. This bending moment you have already calculated, या पहले से कैलकुलेट कर चुके हो जो बेंडिंग मोमेंट आपके पास आ रहा है. बट ऑलवेज रिमेंबर दैट द लोड विच इज कमिंग, दैट लोड फॉर विच द बेंडिंग मोमेंट यू आर कैलकुलेटिंग, दैट पर्टिकुलर केस शुड बी दैट केस जिसमें सेटिस्फेक्शन हो रहा है. मतलब क्या हुआ, जैसे फॉर एग्जांपल सबसे पहले आपने क्या किया था, सबसे पहले व्हाट यू डिड इज दैट यू जस्ट अज्यूम द वैल्यू ऑफ डी टू बी 800 और उसके बाद आपने बेंडिंग मोमेंट निकाला 400, बट वो कंडीशन सेटिस्फाई नहीं हुआ, वो कंडीशन हो गया फेल यहाँ पे आके. उसके बाद आपने क्या किया, यहाँ पे दोबारा से डी को अज्यूम किया, फिर से बेंडिंग मोमेंट निकाला. इट मींस दैट नाउ व्हाइल कैलकुलेटिंग द एरिया ऑफ स्टील यू हैव टू consider this bending moment. Why this bending moment? Because you are providing the depth which is equivalent to this bending moment. इसके अकॉर्डिंग आपने डिजाइनिंग की है. It means that now the bending moment which you will provide, that bending moment which you will consider for the design, this will be bm dash, which is the next moment in which the condition is getting satisfied. So this bending moment which is equal to bm dash, this should be equal to sigma st ast. This is equal to d minus xc by 3 because xc is equal to xa. So you can just equate it with this sigma st value. As you know, you are designing for the balance section, so this value will be equal to 230 Newton per meter square because steel will reach this final value. Steel अपनी final value पे पहुंचेगा ही पहुंचेगा. Area of steel you have to calculate. D you already know, xc you already know. So it means that bm dash you have already calculated here. जब आपने calculate किया होगा, you can calculate the value of area of steel here. उस area of steel के बाद you will assume the dia for the bar. You will assume a dia, for example 16 to 25 तक कुछ भी आप assume कर सकते हो, and then you will calculate the number of bars, that is equal to AST divided by pi by 4 into जो भी dia आपने दिया है का whole square. उसके बाद एक सेक्शन बनाओगे, उस सेक्शन के अंदर जो भी आपने डायमीटर लिया हुआ है बार, उतनी बार दिखा दोगे. You will just provide these bars, जितनी भी बार आई होंगी यहाँ पे, you will provide all the bars. You will show the width, you will show the depth, you will show the effective depth, you will show the effective, cover each and everything you will show. You will write the concrete here M25 FE415. This will be the final design. If you will proceed like this, you will get full marks. Otherwise, you will get less number of marks. Marks तो मिलते ही मिलते हैं, इसमें स्टेप मार्किंग होती है, तो 100% marks will be allotted to you. Fix है वो, marks पक्का मिलेंगे. Fine. तो ये आपको ध्यान रखना है. One question I'll send you on WhatsApp. You have to just solve that question and send it back to me. Just revise these 3 cases which I just told you. These are the 3 types of questions which can be asked in the singly reinforced section of the beam. In the next class, we will cover some distorted type of sections for singly reinforced beam, that is the triangular section, and some weird shaped sections which can be asked in 20 marks question. But till then, just revise this. Go for the previous year, practice the previous year related to this particular topic. It's A.S. Pandit signing off this session. Take care. Bye bye.